All right, let's look at number 3 on the review. Let f be a differentiable function such that f of 3 is 5, f prime of 3 is negative 2. What is the approximation for f of 3.1 using a tangent line? Okay, so I don't need a picture, but maybe it's helpful. F of 3 is 5, and the slope is negative 2, something like that. And we want to use that approximation, or use that tangent line to approximate whatever f of 3.1 is. So it should be a little bit less than 5, is where we're kind of headed with this problem. So tangent line, I need point and slope. Well, the point is 3, 5. They didn't say it as a point, but f of 3 equals 5 is the point 3, 5. Slope, again, they didn't explicitly say slope, but they said derivative, which means slope. So the slope at x equals 3 is negative 2. So we can write a tangent line. Y minus 5 equals negative 2 times x minus 3. That's the tangent line. Now what we want to do is use that tangent line to approximate what the function is at 3.1. So who knows what the function is actually doing? Maybe it looks like that. And so if I zoomed way in, the tangent line wouldn't exactly be the curve at 3.1, but it should be pretty close. So I'm going to move the 5 over. So that's still my tangent line. But we're going to argue that this is an approximation of the function. So f of 3.1 means let's plug in 3.1, and that would be a safe stop. I think this is a multiple choice question on the test though, so we would want to keep going, but that's our approximation. We clean that up a little bit. Negative 2 times 0.1 plus 5, so negative 0.2 plus 5 is 4.8, and that fits what we said earlier, that we think the answer is going to be a little less than 5 based on the picture, and we got a little less than 5. And we don't know what f is, so we can't say for sure how accurate this is. The best we can do is say it's close, and we really don't even know how close. Number 4, let f of x be a twice differentiable function such that f of 1 equals 2. So again, that's giving me a point. The first derivative is y squared minus 3. What is the second derivative at x equals 1? Well, it gives me the first derivative, so if I take a derivative of this guy, I would have the second derivative. So let's kind of start here and do a derivative of him. Derivative of y squared would be 2y times dy dx. That'll be the part that people miss right there, including that dy dx piece. Derivative of 3 goes away, so we're not worried about that. So I want to find the second derivative at x equals 1. So that's 2y dy dx. Okay, so I've got more work to do because I don't know what y is, except that they told me that when x is 1, y is 2. So maybe I could rewrite this as 1, 2. So that'll tell me what y is. I also need to know dy dx, but I have an expression for dy dx. So dy dx at 1, 2. So y is 2. 2 squared minus 3 is 1. So dy dx at 1, 2 is 1. Let's see. Y is 2. And then that 2 out front is still just 2. So 2 times 2 times 1 would be 4. That's a good one. That's a good review question because it had a derivative with the second derivative with an implicit differentiation thing going on with the chain rule, 2y dy dx, and just keeping track of everything. Number 5. Particle moves along the x-axis so that its position is given by this function. For what value is the velocity 0? This is just a review question. Hopefully remember that velocity is derivative of position. So that would be 2t minus 9. And we want to know when that's equal to 0. So what value of t, so solving for time, when velocity is 0, so t would be 9/2. That's an easy one, as long as you remember that velocity is derivative of position. 6 and 7, further review questions. Find the maximum. So the maximum value, that means find the y value of this function on this interval. So on an interval means I better include the endpoints when I'm checking. So table of values, -2 and 4, and whatever critical points we find in there. Critical points coming from derivative equals 0, because if the derivative is 0, then that might be a max or a min when the derivative is 0. So 2x minus 4 is the derivative, so x equals 2 is a potential max or min. So we'll check 2. We don't really care which one it is right now, because we're just going to check all the points. I suppose you could do it the number line way and check to see where increasing, decreasing, and then you know if it's a max or a min, to know if it's even a candidate to be this maximum value. But we're just going to check the points and see what we get. So if I plug in -2, I get 4 plus 8 plus 1 be 13. Plug in 2, I get 4 minus 8 plus 1, so that'd be -3. Plug in 4, I get 16 minus 16 plus 1, so that would be 1. And so my maximum value, or my highest point, is -2, 13. But that means my max value is 13. And that happens at x equals 2, or -2, excuse me. But the answer to the question is the maximum value is 13, because that's the y value that reaches the maximum height. Number 7, old limit problem. Our first go-to is always just substitution to see what happens. I'm going to guess that it doesn't work, but we'll try it anyway. So if I plug in -6, I get 36 minus 18 minus 18 over -6 plus 6. So 0 over 0. So that doesn't help me. But if I factor the top, x plus 6 and x minus 3 over x plus 6. Wow, surprise, surprise. The problem is rigged so that the x plus 6's will cancel. Then I can plug in -6 for x. -6 minus 3 equals -9. So an easy one, but a good review question. We hadn't seen one like that in a while. Alright, so now you've seen all the review questions. I hope you're watching this video and you've seen them all, because this will be a good help, a good preparation for the test on Friday.